John Berryman started out the field in aerospace engineering, but soon found that he was more interested in math and software than in satellites and aircraft. He soon made the leap into software development, specialized in search recommendation technologies. John is now a senior software engineer at Eventbrite, where he is helping to build Eventbrite's event discovery platform. He also recently co-authored a tech book, Relevant Search, which you all know, published by Manning. The proceeds from the book have mostly paid for the coffee consumed while writing it. Without further ado, please welcome John Berryman.
So you've just heard most of the introduction, but here's what I looked like while I was writing the book. Things have been looking up ever since I got my haircut. I'll just skip through this. Just little known trivia, that is actually a photograph of me on the cover of the book. Ask Doug about it later. By the way, everyone always wants to find the slides. The easiest way I found for distributing slides is through Twitter. So that is my Twitter handle. It's my name with all the unnecessary letters removed. And as soon as I finish this talk, I'm going to tweet out my slides. So jot that down if you're interested in seeing these slides later. All right, so let's start with a question. What is tagging, and why would you want it? And before I can completely explain what tagging is, we have to build kind of a shared context. Unfortunately, all of us are search people, so a lot of this is going to be fast. But let's talk about e-commerce search. Back up a little bit. Search is ubiquitous, right? Everything on, search is the gateway to the information on the internet, Google. Search is the backbone for tons of products. It's actually how they make their products available for you. And even if search is not the main aspect of the product or the platform, it's hard to find anything available on the internet that doesn't at least involve search. Now, e-commerce is, of course, powered by search, and this is kind of like the quintessential e-commerce page. So is this Amazon page. You get your facets on the left side and your search results, everything that you guys are all very familiar with. But look at these things. The facets, we call them facets, but everything that you see in, for example, Zappos, what gender are we doing with, male, female, boys, girls, what type of product, shoes, bags, shirts, all these things are facets as far as we're concerned as search folk, but really once you get down to it, these are just pieces of information that you are applying to the products. These are tags. So everything that you see on this page, there's nothing particularly new, especially again to this crowd, but there is changes occurring right now. A lot of you guys have probably noticed a shift because of these guys right here, mobile phones. So what was once an experience dominated by people sitting in front of keyboards and typing and telling us exactly what they want is becoming more and more and more, real quick, browse, response, slice and dice type interactions. So it's an important change. The mobile preference is to have browse over search, and browse, as I just said, is tags. So that's why tagging is so important. So what is tagging? Tagging really is the ability to categorize and understand the inventory that you're dealing with. And why is it so important to get it right? Because these days, tagging, browsing, is powering the emerging dominant e-commerce interaction. So it's becoming a very important thing. So how can you tag your inventory? Well, several options open to us, each with their benefits and their cost. One thing that you can do is have curators to go through the inventory and assign tags to all the products. There are benefits to this. For one thing, you have just very exacting control over the taxonomy that you use. You know exactly what you're going to get, and there's not going to be much noise. But the drawback is that curation, you have to train the curators how to deal with this taxonomy. You have to define the taxonomy, and managing the taxonomy and the curators is a very expensive pursuit. So another thing that you can do is you can require the content creators to actually tag your content for us. And at Eventbrite, that would be the people that are organizing the events and putting them on our platform. And who better to tag your platform than the people that are actually creating the content themselves? They know exactly what they are selling, right? So their taxonomy is in some ways a very natural taxonomy. But the drawback here is you're not paying them. So we've traded very expensive curators for people that you kind of can't pay. And so they're going to want to know what's in it for them. And if they don't see an easy way to connect the dots, then you're just not going to get any tags. So a plausible response to this is the other side of the market, the customers themselves. A really good benefit here is, even though the suppliers know exactly what they're selling, the customers are the ones with the money in hand. And they know exactly how they think through the inventory. And so maybe it's a different way of looking at it, but maybe the customers themselves are really who you should be looking to for developing that natural taxonomy. But the drawback is, the same thing for the content creators is if the customers don't see a meaningful reason to do this, then they're not going to waste the time. You might be able to do some sort of ego play, like on Eventbrite, we've talked about maybe having people curate lists so that they can be like promoters of like the cool things that I know how to do. You can follow them, but it's still a little bit dubious if people would actually put enough time in so that we'd have a rich set of tags. So it all begs the question: what if just no one wants to tag your content? Well, there's an interesting observation. We were working kind of in this area that I'm going to show you a year ago, and it occurred to me. So every day, I got someone calling. Should I answer it? I've got to have the internet, so I can't turn my phone off. So every day, millions of people search for events on Eventbrite. A lot of traffic. They issue in the span of about a month. They issue approximately 500,000 distinct queries, but the top most common 1,000 or so queries accounts for roughly 40% of our search volume. So there's actually a pretty fat, head for the search distribution. The really neat thing, and this is where things started clicking, is if you look at these top most common tags, then you start to see things that really look like, I just said the word tags. They look like tags. These are queries, but they read just like what I would want a curator to assign to this. Business, kids, networking, Christian, free, 5K run, back to school. All these things make sense for how we want to understand our inventory in a very crisp kind of folksonomy. So it begs the question, can we use logged out searches as a way to train a tagging model? And I hope the answer is yes, because the title of my talk is Search Logs plus Machine Learning equals Automatic Tagging. So I, to get to the end of the point, we built something, and I'm going to present here kind of our approach, and hopefully if we have time, we'll have time for questions. You can ask me how I did some of this stuff, but more importantly, maybe I'll ask you guys, a room full of smart people, how we could do better. I'm curious about what ideas you guys would have as well. So the initial idea, assume three things are given. We have a log of everything that you've searched for. We have a log of everything that you clicked that we can link back to the searches. And we have, of course, an events table so that if we know the ID of the event, then we can get the description, the text, all the interesting metadata. Okay, so the approach is such. First, we're going to find the most common, say, 500 queries, because these look like tags. For each search session that involved one of those queries, or actually each search query that involved one of these top 500 most common queries, we found all the events that were clicked. And for every event that was clicked, we extracted the name and description. Based on that, we have a training set. The input to the model is going to be the name and description, the title and body of each event. And the output, we're going to try to make the model where it predicts the query that likely would have led to this event. So, you guys like live coding? Yay! Well, it's a Python notebook, so sorry. I'll push Shift Return. It's close we're going to get. All right. So this first notebook here, it basically walks through the behavior. Everything we're going to do is in pandas. Good. The initial fodder for our model is just as I said. We have the title and body of several events, and then we have the queries that were associated with the clicks on this event. So we know, for example, that makeup class was one of the queries. Beauty was another query that was associated with this NARS summer mega event. Is that appropriate? Probably, because it's at least got the word cosmetic and Nordstrom. And if you look through this, you start to see that, okay, that might be a reasonable way of pulling together a training set. So there's the training set. The next step is to set aside your test and training set, because we're going to build our model with the training set, but we want to make sure that we're obviously testing on data that we haven't seen before, so we don't fool ourselves that we're building a model that's better than it is. The processing of the input text into a features for the model is contained in these really 3 cells. I'll just kind of like wave my hands a little bit. It might be legible. But basically what we're doing here is the input text gets tokenized, and we use this count vectorizer to say how many times a particular word has occurred in text. We use a IDF transformer to do what you guys would expect that would do. It turns the counts into floating point numbers. Then we do that with the name and the description. We then take this big sparse vector, which we're going to see what the size of the vector is in a second. I think it's like 15,000, and we make it dense because that's what the input for the neural network needs. And then we're going to concatenate them together. So the name and description, whatever came out of that is now concatenated together. Let's take a look, see what it looks like. And the full training set that I'm using right now is 14,000 entries long, 13,000 features wide, which is a little bit suspect for overfit, but we actually did pretty good. The number, just to give you a feeling for what is inside each row, I plucked a row out of this, and one example row had 54 non-zero elements, so it's still, even though it's in memory it's dense, it's still sparse. And the number of non-zero elements from this particular row, you get to see, it's TF-IDF values. Processing the target works almost the same way. The only difference is, we don't care about, the input field for the tags. It's just like the tag itself. It's not like a free text field. So we don't care about TF-IDF, but we do use count vectorizer. And basically what used to be like, this document was searched for with makeup and beauty is now like this document is associated with a vector of lots of zeros and a couple of ones associated with those 2 tags. And so this is actually exactly an example of that. The vocabulary we're using, just the way it turned out, it wasn't quite 500, it was 449. But you get an idea about kind of the orders of magnitude here. All right, so building the model. This is the part where, I wanted it to be complicated. I wanted to get my deep learning merit badge with like a stacked 10-layer network. I even tried to do smart things, but the smart things were not nearly as good as just like a simple, I had a couple of hidden layers, and the output layer I was going to do, what's the sigmoid function, the multi-valued sigmoid thing? Anyone want to help me? Softmax, thank you. Yeah, I had a softmax activation on the output, and it didn't do as well as just a bare output, which I don't understand. You can help me maybe. But you can see how I put the model together here. Just 2 hidden layers. First layer maps from the very broad input space down to about 500. The next layer, and it has a ReLU activation. Next layer just does another linear manipulation of that with a bare output. And we fit it against the training data, and save it. It takes, I'm not going to run it. I'm actually pulling from disk. But it doesn't take long. It's about 10 minutes or so to get pretty reasonable results. And the results are in. All right, so the way that we're going to read this is, the truth is this. So this is the original text, some sort of around the world beauty travel meetup. It was found with a search for beauty, and our algorithm predicted beauty. Great, so that works. So now you kind of get the idea of how it looks. So let's just take a look at how some of these things work. The truth was the leadership seminar, and we predicted all sorts of meditation, mindfulness. It kind of makes sense because it's pulling off like some exact matches to words, and those are usually really good signals for this type of stuff. And this mindfulness has become a buzzword. So even though this is a leadership seminar, it's a leadership seminar that's focused on meditation. This one appears weird until you know our business model. Most people don't go like actually looking for a bridal show to attend, but they're looking for like things that they can work on. Most people are looking for events. They want to attend something. But there's a group of people that search our website looking where they can be a vendor at, say, a bridal show. So even though this was clearly a bridal show, people were looking for ways that they could interact with their customers. 5K run, memorial. Oh, this is interesting. We've definitely nailed it, but changed the word. That'll come up soon. And here's another example where someone searched for Comic-Con and it was anime. So without going through the whole list, it's doing a pretty good job, right? So let's jump into the presentation again and review what we've learned thus far. So by visually inspecting it, we're doing pretty good. But it's not without issues that we should address. For one thing, we have several instances of near synonyms. I just showed you that one example with Memorial Day. This data set, by the way, was from around Memorial Day last year. So like Memorial Day weekend events, Memorial Day weekend, all these things were very, very, very popular tags, but obviously they're effectively asking for the same thing. So we've got a little bit of an issue where you can tag an event 3 different ways, but each tag is actually the same thing. We need to deal with that. Somewhat related to that issue, we have an issue with a small tagging vocabulary, because we've said we can tolerate pulling down the 500 most common queries, but of those 500 most common queries, we're getting like all these weird duplicates. So like the actual true vocabulary is a subset of 500. It's not going to be that big. And we would like to have a breadth of vocabulary so we could describe, in principle, whatever event we might host on Eventbrite, which is a very, very, very broad field. And finally, you probably noticed most of those examples that I showed you, we are getting tags, but we're getting like 1 or 2 tags for each event. We're not getting just tons and tons and tons of tags. And this is, we're going to improve on this, but even this is still going to be kind of an issue as we even improve the model. We would like to have something tagged almost hierarchically. Like this is a developer event, this is a Java event, this is a some sort of very specific. We would like tags to look like that. So we're going to lump that into stuff I still want to do and ask you guys to tell me how to do it later. But in the interim, let's look at how we can at least improve the current model and take care of some of these issues. One of the ways that we could improve this is by taking into account a full session. Oftentimes, you see interesting behavior from the users that you can learn from. Whenever they're typing something in, they might realize that they've made a spelling mistake, that we could just, we can see this in their search history. They're refining and revising searches. They might type in something, be dissatisfied with the results, and look for synonymous words. So it's like we're automatically generating synonyms based on their sessions. They might do different refinements, broadening, narrowing searches, just depending on how stuff looks. And all of these things are clues about how these tags are interrelated. That'll give us a clue about which tags we can do away with, and in the future will even give us clues about how the tags are related to one another. So the idea for improvement, let's take a moment, look at these statistically significant query strings that are occurring together in sessions and figure out a way to train a neural network based on the natural grouping that we see from our user data. We have 2 notebooks for that. We are a little bit time constrained, so I'm going to skip some of the details. But I will be around later, and these are published online, so you have access to these as well. All right, similar, different training set. Effectively, we're doing something very different in this notebook than the previous one. In this notebook, we are looking at the words that co-occurred in the session. And here, after doing a fairly complicated query, here's the results that will count as our starting set for this analysis. Memorial Day weekend, we see that it occurred 4,976 times with Memorial Day weekend events. So effectively, every row in this is defining an arc on a graph. Each word on the left or the right is a node in the graph, and the edge weight says, how many times that this word, this query, co-occurred with this query. All right, so a lot of these are near synonyms. So we see people like doing like slight clarifications, like pluralization for job fairs and car shows. But if you were to scroll through this list, we get a lot of interesting stuff where people are narrowing and broadening searches, doing all the things that I talked about on the previous slide. Now there's an issue that we have to deal with where certain tags are inordinately popular. This is very, very akin to the reason that we use document frequency to normalize terms in a search index. A lot of people searched for Memorial Day and then search for something specific. Like, I want to do something to do this weekend, and since Memorial Day was like that weekend where I get the data set, they would type it in, see way too much stuff, and they say, oh, okay, well, I guess I'm really interested in something narrow. Because of that, this arc between Memorial Day is attached to everything, and we want to do something to kind of artificially like kick it back so that it doesn't get associated with everything. So the way we do that is we say, okay, Memorial Day weekend events, it occurs a lot of times with Memorial Day events, but how many other words does it occur with? And apparently this one occurred with 10 other queries. And so if we take the total number of occurrences divided by the rows that it appears in, that's kind of a way of normalizing the results out. We also tried doing the number of times that it occurred, but the cardinality of rows worked better than the number of searches, the bare number of searches that it was involved in. All right. Given that, then we take effectively this matrix, this long list, and we do the pivot table of it. We say all the columns should be stuff from node A, all the row headers should be stuff from node B, and then the values in the matrix are going to be these normalized edge weights. And so we get a matrix that is for the current number of words. It's 2,649 words that we're trying to find the co-occurrence counts, the normalized co-occurrence counts. And a subset of the matrix is going to look like this, just to give you a glimpse of what it might be like. Mother's Day occurs with mother with a value of 2.8, but occurs with Memorial Day weekend stuff with like a very small fraction of that. So it just kind of gives you an idea about how stuff clumps together. We use, I won't get into the details, but we use an algorithm called affinity propagation that allows you to I'll get into the details a little bit. It basically, every node in the graph with this affinity propagation, it effectively wakes up, looks at whatever nodes it's attached to, and it says, I think one of us is the boss. You guys vote on who you think is the boss based on what you see, and I'll vote too. And you iteratively do this, and over time, you start to get a clustering of the nodes and who they think is kind of the center of their local network. And so this affinity propagation allows us to start clumping together pieces of the graph, and we get data sets that look like this. I've got to always read this really fast because I was stupid enough to put like a random sample, and occasionally we have some pretty risque query stuff going on. But in this little chart right here, we can see that we have clustered a lot of words together, and we can see that by and large they do pretty good. Here's all the words associated with a single cluster, and here is the number of terms of queries in that cluster. And this rightmost column is actually maybe the most important column. It is they all voted for the boss. This is the node that represents the center, the local center of this cluster. So we get, sewing class, sewing. We get Summer Jam Fayetteville as Summer Jam. So we're just kind of chopping out the stuff that was less common. Food and Wine Festival, food tasting, wine events, wine tasting events. Arguably, those could have been two different things, but they clustered into wine tasting events. So kind of neat. And if you guys will get a chance, I guess, to play with this yourself, it does a pretty good job about collecting stuff together. So based on that, we can do. This is kind of the boring part of the notebook. I don't think we really have to learn too much from it. The basic idea is, what started is a matrix of, here is our top 2,600 queries, row headers. Here is our top 2,600 queries as the columns. That giant matrix, we've effectively compressed it down. We've said, okay, so still in the row header, we've still got 2,600 rows of all the popular queries, but we're going to collapse them down. I'm zeroing rows out, and for the only rows that remain in the column space is going to be the most common, like 500. Much smaller vocabulary. We've effectively squished out the things that are synonyms or near synonyms, and then this is the chunk that we need to improve the model. And let's do that. So improving the model. So I showed you in the first notebook, the basic model worked pretty good. We're going to rebuild all of that, but a little bit wiser with our understanding of how the clusters and clumping of the queries actually takes place. So, oops, bottom of the notebook. Uh-oh. Oh, no, there we go. So we started with a similar data set as before. There's actually a little bit more information. But you see again here, we have the name and description of the events. We see that we have the queries associated with these events. So someone typed in Cinco de Mayo and clicked this booze cruise. Seems appropriate. And the extra piece of information that we have is the count of the number of queries that are associated with it. So I'm being a little bit sneaky here. I'm doing a little extra work that I haven't told you about. Not only are we collapsing the query space into a crisper vocabulary, but we're also incorporating more understanding about like how much traffic each of these queries got. So we know how important a tag is. And you see stuff like here. We see we can differentiate like how important a particular tag is against a couple different queries at a time. And this is also a good example of where it needs to be collapsed. We have effectively the same thing that was queried two different ways. All right. Oopsie. This one takes about 10 seconds. What is it doing? It's creating a matrix of wrong label. Well, what is it doing? It's taking so much time. Oh, it's done now. Let's see what it prints out. Okay, so the initial part of this notebook, I'm just kind of like, whenever I'm doing any exploration like this, I want to spot check and make sure that the data looks about right. I'm taking out some events that had co-occurring queries and just make sure the data looks right. So some event 369794 had 13 points associated with blockchain and 3 points associated with crypto. It's just a spot check. But effectively, I've got a list of every event and all the queries that were associated with events. So now I want to take that matrix. We're into matrix multiplication at this point. Have you guys, Python fans, have you guys ever seen this operator? It was actually new to me. It's pretty amazing, right? This with Python 3 NumPy, you can use the @ operator to multiply matrices together. So it's really cool, because what we were getting ready to do was effectively, for every event, we're going to look at every query associated with it. And for every one of those queries, we're going to look at our big cheat sheet of all the queries and find out the boss query for that row. We're going to do that for all of them. And that's like a 2 or 3 level 4 loop, and it's just a pain in the butt. Or if you think about it as a matrix, it's a matrix multiplication. It's a one-liner. So, because math is the coolest. So that's neat. And just to make sure that, here again, I'm spot checking before I actually create the algorithm. There was some event somewhere that was associated with these 3 queries: yoga retreat, free yoga, yoga events, and they all got lumped into the yoga category. Vendor opportunities got stuck in the vendor. Third space, I had to look it up, but it's basically a yoga thing that's highly associated with Lululemon, so probably pretty reasonable. So we're still on track. The next thing is, now we're at the point where we have the training sets completely made. We're at the point where we actually can build a model. We're at the same point we were with the first notebook. Set up the testing training set, just like I showed you guys that first notebook. We're going to do the pipeline again, very much the same thing, with taking the TF IDF process the words down to dense vectors and concatenate them together. And the only thing that's, do I have it here? The only thing that's just a little bit unusual is that the tags, they used to be just queries, and we turned them originally in the previous notebook into 0001, 001, this in hot vector, I guess. It has now got a little bit more nuance to it. It has floating point values for not just the presence of a query, but just how strong the query is. All right, so we're going to build the models and look at some of the outputs. All right, so similar setup as before. It was associated with an actual query, a 5K run. We predicted 5K run. That's good. This one is associated, this is interesting. This one was associated with a query for wine, but we predicted this list of 20 tags. It's like, well, that's got to be wrong. Except that, if you start looking at it, Afro's there, Caribbean's there. It appears to be some type of day party. Memorial Day weekend events, I'm a little bit suspect because, that got a little bit over-associated with stuff. But Reggae Fest, so this is like Afro beats with sweet Caribbean music, that actually seems like a nice inference from the words in this. And it is actually associated with wine and wine tasting. So, I just happened to, this happened to be at the top of my example set, but I feel like this is kind of validating for the work that we're doing. But everything else seems pretty reasonable too. You don't always quite get as many tags as I would like, but you do get more tags than we did last time, and they seem to be surprisingly accurate. Here's another one kind of like that. Blockchain got to turn into blockchain pitch, startup, and venture capital, but you realize that it is actually a startup pitch competition associated with cryptocurrency type stuff. So it's pretty neat. I think it's looking like it's going to work out pretty well, and we've actually deployed it to some success. But we're very much at the beginning of this. So back in the presentation, we'll wrap up. There are some things to notice with the second approach, this more advanced approach. For one thing, there is much fewer of these spurious synonyms. It's just like one tag per idea, which is exactly what you want. So instead of Bitcoin and blockchain and this misspelling, just blockchain. Perfect. There's also a lot more sample data. This is, I think, the killer part of the evolution of the model. The first model, we were associating it with 449 of our most common queries. By virtue of casting this really wide net, 2,600 some odd queries, and then collapsing it, we have a model that's just as easy to train and deal with, but we have a much broader topic space. And it actually, I told you that 500 accounts for like 33% of our traffic. Once we zoomed out to 2,649, that's associated with over half of our traffic. So this appears to be a good way to really nail the short head of search tagging. And finally, there are a lot more broader tags because we have still roughly the same vocabulary space, the same 500-ish slots once you condense it all, but we can talk about a lot more things since the slots aren't being taken up by spurious synonyms. But with every good thing, there's the drawback, right? So there's an issue where, because of the way we've done it, you can occasionally get spurious associations. AI and blockchain are commonly queried together, but they're not the same thing. So that's a frustration with that. And I have to explain this one, but it's even more frustrating. I had to look up Ozio and Rose Bar. Ozio is a bar in Washington, D.C. That's a pretty hot place to go on the weekend, apparently. But if you don't find something to do there, then you want to find something in a Rose Bar. So I've effectively associated two, arch enemies as being like synonymous in our tagging set. So curation might be useful at some point. Lots of neat things that we would like to do with this as we go into the future. The ability to actually power faceted searches. That's something that we did deploy, and we had a nice little uptick in the user engagement. The ability to infer relationships between tags. So blockchain is highly associated with AI rather than synonymous. We would like to be able to be very explicit about how things are associated, and we can use these things, that information internally to understand our inventory, but also to provide feedback to organizers and say, as you're typing an event, here is, you might mean this, or you might be associated with these fields, or something like that. Or if you use a different term, you'll get more search hits. We could provide a lot of neat feedback for our organizers as well. We can use the tags for better recommendations. If I know you've searched for something, then I can actually stick that onto your user profile, and I can use that later. But if I know you've searched for something, and I can basically provide this association analysis, I can save not just the thing you typed in, but I can save a lot of stuff about your interest as these tags. And finally, something that we just haven't really had time to look into is using what we're gathering here for things like search synonyms and being able to broaden searches semantically. Future work, we're covering the short head really well. There's the long tail of search that is going to be an interesting challenge. It feels like it's probably going to need a different approach because as the information gets sparser and sparser, but that'll be interesting. We do have issues where the super short tail queries might be artificially associated just because it's so commonly queried. And of course, there is a problem where if someone types in Kanye West and we just don't have a Kanye West event in our inventory, you don't have that in the training set. So there are some shortcomings to this particular approach. But it's a fun problem. It's been a really interesting kind of mental excursion, and I look forward to hopefully doing more of this in the future at Eventbrite. So we got about 5 minutes left for questions, or you guys telling me how to improve the model.
So I saw that you used event propagation to basically cluster out and to identify the best centers. Did you look at other cluster analysis techniques? Because it seemed that a hierarchical clustering where you pull out the dendrogram and then walk it would be to give you a different kind of control over the granularity of your tags eventually to go for broad or narrow. I'm just wondering if you had looked into stuff.
No, that's a great idea, and because we would like to be able to tag things more hierarchically, so if the tags naturally come out, if the taxonomy has a little structure to it, I think that would help a lot. A lot of the stuff that you see this is really just kind of it's an experiment that we deployed. So this is very much, it's been over the past year. We slow roll things occasionally at Eventbrite. But this is very much like, us kind of dipping our feet in the water and figuring out how to deploy data science products into production. And so we're looking for a lot of good feedback like that. Thanks.
It's very interesting. I just did something very similar to this. I can talk to you in detail. But one, you're going to have trouble deploying TF-IDF into production if your data set is large. It's going to take a lot of memory. And two, I do agree with the gentleman that said before, you might want to try out clustering approaches, because clustering, you can specify how many clusters you want. So this sort of gets away about your problem if you only have 500 or 400 predefined categories. Mm-hmm. And then if you do clustering, then you probably want to invest in a really good vector representation of your documents. Mm-hmm. So you can maybe think about moving beyond TF-IDF to try some dimensionality reduction techniques like single value decomposition, or you can probably also do some representation from word vectors. I tried a couple of those and they seem to work really well.
Okay. Thank you very much.
So your tags are queries, right? That people
Yep.
have. So is there a problem with bias there a little bit, or concern about bias, because you're only going to tag documents that are reachable by your current search engine?
Oh, yeah. And that's actually, I kind of called that out real quickly on the last slide. One of the issues that we have is like the Kanye West thing is, like, if you search for something that we just don't have, then that's not going in the training set at all. So there will be a bias. And how to deal with it is going to be interesting. One of the things that you might have noticed I effectively skipped over is like how to validate that our models are returning anything good. Now, we did it with our eyeballs, and it looked good, but it poses a really interesting challenge, because if we have a situation here where we might have a really high accuracy for the model, but that might not be as good as what you could get, because like the event that was queried with wine, we associated with 20 different, the Afro-Caribbean wine. The result was great, but there's no way that the training set would really indicate, or the test set would really indicate, you did above what you should have done here. So there will be bias. Dealing with it's going to be interesting, and to kind of go into that a little bit, the best idea that I've actually had coming from an audience was a data scientist at Lowe's that said that they use their content creators. They provide recommendations for what they should tag stuff with, and if it's accepted, then it's good. And that's an interesting way of at least becoming aware if we have a bias in what works and what doesn't.
I mean, you could look at ones where they've gone quite deep in the search, and so it's less influenced by the top results, maybe. But the other concern is like you're kind of changing the algorithm, like by adding these tags, and so then you're changing your training data to some extent.
I don't see a positive feedback type scenario yet. Not in the way that we've dealt with it. Because if people are the source data set is people typing in searches and not clicking tags, and then the results get associated. The tags get associated with events, and some people choose to browse. But we're not taking that as the input for the training. So there's no feedback in that sense.
Okay, one last question.
Obviously, this might be something you consider later in the process, but have you thought about how to deal with kind of negative indications where, okay, somebody did, say, search against that tag and they skipped events 1 and 2, and if that's happening very consistently, maybe it's a correction to the model?
So like if they searched for day party and like just went past the first page, I mean that'd be a good indication that we've screwed up something with that tag. Is that kind of what you're getting at?
Yeah, that's what I mean. As you start to promote this event as being affiliated with this tag, then you get a lot more hits with people that might browse using that tag, but they're just nobody's clicking that first result.
That's okay. So this is another good idea from the audience. So we just talked about using the content creators to judge your tags, But that's kind of a sneaky way that we can also get the browsing users to vet the accuracy of our tags. I haven't thought about that, but that doesn't seem terribly hard. So I love question and answer sessions where I just get to ask you guys the questions and get good advice. Is that it?
I believe that's it for the time period that we have.
One quick final note, since I have the bully pulpit. I did share this on Twitter, so there's your final reminder. There's links in here. This is, you can click on stuff. But also, I've got a couple of advertisements. I'm associated with this group called Data Nerds. It's kind of like aspiring people that are trying to become data scientists. And probably more important for this crowd, I am associated with a group called Penny University, which is a kind of a grassroots peer-to-peer learning community. If you have something that you are available to teach and you don't mind sitting down with someone for 30 minutes over coffee, or if you have something that you'd like to learn, like, teach me React in a weekend, we're a community where we're really forward with meeting with people, engaging in real life, and just helping out with stuff. It's a pet project of mine right now. Thank you.
Thank you very much, John Berryman.
Thanks, guys.